Welcome to our educational channel from class 10th mathematics to chapter 4 linear inequations. Now in this chapter, so first we'll see the introduction about this chapter. Next, linear inequation in one variable. Actually this chapter is based on only one variable. So what is the inequation and what is the linear in this? Solving linear inequations algebraically problems, replacement set and solution set. So difference between them and see. And important thing is representation of solutions on the number line. And together like combining inequations problems and what is the zero product rule in inequations. So these are the important topics including each and everything we'll discuss in this chapter. Right, those are watching first time, you can see the links in description below for the other chapters, and complete information website is providing in the description. Right, and now let us start the basics in this. First, when you come to this inequation, equation is the equal symbol, right? Equation symbol, there should be equal sign. And when you come to inequation, let us take greater than is a less than or greater than. X is less than y, x is greater than y. These are the symbols we'll use. For example, 2 is less than 3. Okay, 4 is greater than 3. This we know. Now, when you come to this inequation, 4 conditions will apply. So, one is less than, greater than, along with this less than or equal, greater than or equal. Okay, these are the 4 conditions will apply. Less than, greater than, less than or equal, and greater than or equal. Okay, each of the 4 conditions given this above is the inequations, right? Only the equal sign is the equation. Apart from that, these are the 4 conditions. Okay, and representation. So like x is greater than or equal to 5. X is greater than or equal to 5 means 5 also is included, right? Even minus x plus 4 less than 3. These are the examples for the inequations. Only in one variable. Variable should be only one, either x or y. Like y plus 3 less than or equals to 3y. Now this is the linear inequation in one variable. Okay, only one variable, either x or y, only one variable we need to apply. Okay, now let us start the linear inequations. What is the conditions in this in one variable? Linear inequations in one variable. So many of you will confuse even the notation also. So we have the signs of inequality. Only 4 are there. So one is, for example, if A, B, C. Let's take A, B, C are real numbers. These 3 are real numbers and x is the variable. Then each of the following linear equations we can write. So for example, ax plus b greater than c. Only 4 notations. And ax plus b less than c. Ax plus b, yeah, greater than or equal to c, and same ax plus b less than or equal to c. Okay, so these are the 4 notations inequalities we can use in this chapter. We have only 3, 4 are there. In the inequation, the signs greater than, less than, greater than or equal, less than or equal are called sign of inequalities. Okay, see the example. Like 2x plus 3 less than 4, 6x minus 4 greater than 5, like 3x plus 2 less than or equal to 4, 2x plus 6 greater than or equal to 6. Okay, these are the examples. In this all we can see only the 4 inequalities: less than, greater than, less than or equal, greater than or equal. So remember, so this symbol is, we can read it as ax plus b greater than c. Now this symbol is less than. Now this is greater than or equal, less than or equal. Okay, these are the 4 only we can use. Now how to solving these linear inequations? These are the type of inequations. How to solve algebraically, step by step. We have around some rules are there, around approximately 6 important rules. Without any mistakes, how to solve the linear inequations algebraically. Let me explain now. Solving a linear equation algebraically. So to solve the linear equation means, so for example, let us take one example here. If it is 3x plus 5 is greater than 8. Now this is a inequation, one variable. So linear inequation, one variable it is. To solve the given linear equation means to find the value or values of this variable. Okay, this is x is a variable. So we need to find the value of this x. Okay, only single if you take like x is less than 2. That meaning is x value is less than 2, like 1, 0, minus 1, minus 2, so on. So that means finding the value or values of the variable used in it. No, this is nothing but solving linear equation. To solve these linear equations, we have some rules. Okay, this is the inequation. For example, rule wise I'll explain, then you can remember the concept easily. The first rule is on transferring positive term to other side, it becomes negative. Okay, positive term, if you interchange to another side, means LHS to RHS or RHS to LHS side, it becomes negative. See example. 2x plus 3, so is greater than 7. So 3 is the positive term. When interchange on transferring a positive term from one side of the inequation to its other side, then the sign of the term becomes negative. Sign of the term becomes negative. Plus 3 it is, right? If you transpose, it becomes minus 3. Now this is 2x, same sign. 7 plus 3 is minus 3. So positive term becomes negative term. There is a transferring a positive term from one side to other side, it becomes negative. Even 23 greater than or equal to 4x plus 15. Here is 15 is the positive term. If you transpose other side, one side to other side, 23 is greater than 4x. This 15 transposing, it becomes minus 15. Okay, sign will be changed. That is positive term becomes negative. Same rule 2 also. This is just quite opposite for first one. If it is a negative term, transposing, it becomes positive term. Okay. See one example. The same example you see once previous, like 2x minus 3 if you take. 2x minus 3 is greater than 7. Then minus 3 is a negative term it is. So negative term becomes positive by transferring another side. 7 plus 3 minus 3 becomes plus 3. Okay, these are the simple rules, rule 1 and 2. And next 3 and 4. Total 6 rules I'll explain in this so that you can remember easily how to solve. Now when you come to this rule 3, here is if each term of inequation will be multiplied or divided. Let us take, for example, x is less than or equal to 6. Each term of the inequation be multiplied or divided by the same positive number, then sign of inequality remains same. Same positive number if you multiply both the sides. Now for this, if I multiply 2 both the sides, so 2 into x less than or equal to 2 into 6. 2 into 2 into same positive number when I multiplied both the sides, inequality does not change. So this is nothing but 2x is less than or equals to 12. X is less than or equal to 6, no, then 2x is less than or equal to 12. Not only multiplied, even divided. Dividing case also. For example, x is less than or equals to 2. Divide by positive term. X divided by 2 less than or equals to 2 divided by 2. Then x divided by 2 less than or equals to 1. So same, x is less than or equal to 2, exactly x divided by 2 less than or equal to 1. That means if each term of the inequation be multiplied or divided by the same positive number, then inequality sign does not change. Okay, like rules we can write in this type. If x is less than y, then px is less than py. So here is p is the positive number, only positive. Same way, if x is greater than y, if any number is multiplied, px is greater than py. So here is p is not equal to 0 and p is positive. If any positive number, if you multiply it or divide it same way. And similarly from this also we can take divisions also you can take like x by p less than same y by p for this first one. Same x by p is greater than y by p. So it does not change. That means on multiplication or dividing same positive term, both the sides, inequality does not change. Okay, this is the important rule. Now if it is negative, what will happen? Okay, let us see rule 4. If each term of the inequation be multiplied or divided same negative number, what will happen? So inequality sign should be changed. If it is negative number, let us take x is less than or equal to 6. Both sides if I multiply with negative 2, in case if I multiply both the sides negative 2, okay, this side is 6, right? X is less than or equal to 6, both sides negative 2 when I multiply, then inequality sign should be changed. So if it is less than or equal becomes greater than or equal. So minus 2x greater than or equals to minus 12. This is very important. When you multiply or divide with the negative number, both the sides, inequality sign should be changed. See why the reason. We know 2 is less than 3. If I multiply with minus 1 both the sides, then this becomes minus 2 minus 3. So 2 is less than 3 but minus 2 is greater than minus 3. Right? One equation, or else minus 3 is less than 5. Negative 3 is less than 5. If I multiply with minus 2 both the sides, then what will happen? Minus 2 into minus 3 is 6. 5 into minus 2 is minus 10. But 6 is not less, so it becomes greater. So inequality sign is changed, you see. Okay, it's important rule. When we multiplied negative, not only multiplied, even divide. When you divide or multiply with the negative number, both the sides, inequality sign should be changed. Right? This is the rule we need to apply. And when you come to this rule 5, both the sides. If sign of each term, both the sides of inequality changed. Both sides if we change also same it is. Minus 2, okay, both the sides means minus x is less than or equals to minus x. Then both sides if we change the sign, if I want to change this both the sides, both negatives becomes positive means in this case also it should be changed. Okay, this is actually rule 5 we can take. In case both are negative, if you change the sign, then this inequality sign should be changed. Okay, and next the last rule, rule 6 to solve. If the reciprocals, for example x is greater than y, reciprocal of x is 1 by x, reciprocal of y is 1 by y, then greater than becomes less than. That means if both the sides of inequation are positive or both are negative, inequality. If both sides of the inequation are positive or both are negative, then taking their reciprocals, the sign of inequality reverse. Inequality must be reversed here. Okay, let us see one example. 3 is greater than 2, right? But 1 by 3 is less than 1 by 2. Both positive or both are negative in that case only. Even minus 3 is less than 2. But one is negative, one is positive, should not consider. So only both must be negative. So minus 3 and is less than, for example, if you take minus 4, generally on number line 0, this side is minus 1, minus 2, minus 3, minus 4. So minus 4 is less. That means minus 3 is greater because minus 3 is right side, minus 3 is left side. Some more. So if minus 3 is greater than minus 4, then reciprocal of this minus 1 by 3 minus 1 by 4, then greater becomes less. So simple rule, if both sides are negative or both sides are positive, If you take the reciprocals, then inequality sign will be reversed. Yes, these are the 6 important rules we'll apply in these problems, and when I'm doing the solutions for the inequations also, I'll explain again. In this linear inequations, replacement set and solution set. Let us see what type of the problems we can solve in this type. For example, the linear inequation is 3x plus 4 less than 16, and here is x is belongs to n is natural number. This is belongs symbol. Now this is a replacement set. The set from which the value of the variable x is to be chosen is called the replacement. So for this solution, we need to choose the x value only from the natural number. Okay, and it is a subset whose element satisfy the given inequation. Okay, is called the solution set. See this problem. So now x belongs to natural number. So this is the replacement set in this. Now solution set is a subset from this natural number which is satisfy this inequation. Okay, 3x plus 4 is less than 16. So 3x less than 16 plus 4 transpose minus 4. 3x less than 16 minus 4. So it is a 12. 3x is less than 12. Divide with the positive number. 3x divided by 3, 12 divided by 3. Dividing with the positive number does not change inequality. 3 cancel, then x is less than 12 divided by 3 is 4. Okay. Since the replacement set is equal to natural number, therefore solution set only we should choose the numbers from the natural numbers. X is less than 4. Less than 4 is only 3, 2, 1. 0 should not be, because 0 is not belongs to natural number. So solution set is which is chosen from the given, that is a replacement set. Right, let us have one more question. X condition is given, so based on that we can take. And one more, solve the linear inequation 5x plus 4 less than or equal to 24. Let us take in this x is belongs to whole numbers. So you have to choose the solution set from the whole numbers. So whole number is a replacement set, right? You can use this transposing 5x plus 4 transpose minus 4. 5x is less than or equals to 20. Divide by 5 both the sides. 5x less than or equals to 20. So divide by 5, divide by 5. Because 5 into x it is. So cancel. X is less than or equal to 20 divided by 5 is 4. Here is x is less than or equal to 4. So then solution set we can write only from the whole numbers. Whole numbers starting with 0, 1, 2, 3, 4, 5, 6, so on, right? So but x value less than or equal to 4. X is less than or equal also. So 4 also included. 4, 3, 2, 1 and 0. So 0, 1, 2, 3, 4 is the solution set. Okay, this is the replacement set. From that we have to choose the solution set. This is the difference between replacement set and solution set. Having one more question. For example, if we take integers. Now find the solutions for the given 15 minus 3x greater than x minus 3, where x is belongs to I. Integers. Integers is all the negative number, positive numbers including 0. So all the natural numbers are in whole numbers. All the whole numbers are integers, again negative also. Already number system, only from integers we have to choose. Okay, let us solve this. To solve this one, 15 minus 3x greater than x minus 3. X minus 3, if this is greater, no, this is less. We can do two methods. X terms one side we can take. This is positive x. If it is minus 3x, it becomes minus x. Minus 3 plus 15 is minus 15. Just these both I transpose. Positive x is negative x, plus 15 is minus 15. minus 4x is greater than minus 18. According to inequality rules, when the both sides are negative, if you change the sign, inequality should be changed. So less becomes greater when it is 4x and 18. Okay, 4 into x. So x is less than 18 divided by 4. 4 into x, now I can divide by 4 both the sides, cancel this. Then x is less than 18 by 4, 2, 9, 9 by 2. That means 4.5. X value is less than 4.5. Then solution set. So when you come to the solution set, x belongs to integers. X belongs to integers, but x value is less than 4.5. X value is less than 4.5 in this. Okay, so 4.5 means next it is a 4, 3, 2, 1, 0. Even integers, negative, minus 1. So on. Infinite till negative side. Okay, this is the condition we can apply. Right, x is less than 4.5, so we can consider this. These are the main things we need to apply to follow to find the solution set. Only from the set which you are choosing, there is a replacement set. Representation of solution on number line. So in this linear inequation, after finding the solution set, that we can represent on the number line. So to represent on the number line, I will show the 4 different ways. Here we have x belongs to R means x values belongs to real numbers, and x is belongs to natural numbers. Okay, and x is belongs to whole numbers, x belongs to integers. Okay, these are the 4. Now for example, first case, representing on the number line, x is belongs to real numbers, and say x is greater than or equal to 3. Okay, that means now this is 0, 1, 2, 3, 4, negative 1, negative 2, so on. X is greater than or equal to 3. From 3, all the values right side. 3 is included. So because of 3 is included, we have to keep the darkened circle. Darkened circle, and from here all the values towards right side. Because x value is greater than or equal to 3. From 3, all the values till this arrow, and extend not only 4, 5, so on till infinity. We have to keep like this. Instead of that, only if for example same x belongs to real numbers and x is less than, okay, for example x is less than minus 1. If x is less than minus 1, minus 1 is not included. If x is less than minus 1, minus 1 is not included. We have to keep the hollow circle. X value is less than to this, so all the values towards left. We need to keep this. So this is for x is less than minus 1. If it is x belongs to real numbers only, we can draw the line on the number line again. If it is already values belongs to, the value is included, we can keep the darkened circle, or else this hollow circle you can keep. And remaining are simple. If it is a natural number and minus 2 less than or equal to x less than or equals to 4, x value between minus 2 and 4. To represent on the number line, natural numbers, so 0, 1, 2, 3, 4, 5, minus 1, minus 2, so on. Here is x value between minus 2 and 4. Minus 2, minus 1, 0 is not in natural numbers. So only 1. So we need to keep only the circle, darkened circle symbols. 1, 2. But they are not, okay, 1, 2, yes, 3, 4. 1, 2, 3, 4. Between minus 2 to 4, which are belongs to natural numbers, only 1, 2, 3, 4. So from the solution set, we can represent even whole numbers, integers also same. First, we need to find out the solution set according to this rule, which is given replacement set. No, based on that, we have to represent on the number line. Different problems we'll see, you'll get more clear idea about this. Okay, let me take one question. Find the solution set and represent on the number line. Question is minus 1, less than or equal to 3 plus 4x less than 23. These are two inequations, inequality signs. Okay, these type of problems, first two we should take. That means minus 1 less than or equal to 3 plus 4x. Here is replacement set is x belongs to real numbers. We have to represent on the number line. First both, minus 1 less than or equal to 3 plus 4x. And last two, that means 3 plus 4x less than 23. Okay, first two and last two, middle will be repeated. Now solve separately, this side and both the sides. 3 take this side, minus 3. So it becomes minus 4, 4x, right? And divide by 4 both the sides. Then minus 1 less than or equal to x. Okay, when I divide by both the sides, 4. Minus 1 less than or equal to x. Let be equation 1. Here is 4x less than 23 minus 3. We already know the rules how to solve. 4x is less than 20. Divide by 4 both the sides. Then x is less than 20 by 4 is 5. X is less than 5. From 1 and 2, from equation 1 comma 2. Together, minus 1 less than or equal to x. Then continuation is x is less than 5. Where x belongs to real numbers. So this one we can represent on the number line. So number line for this is x value between minus 1 and 5. So observe here, minus 1 is included because minus 1 less than or equal to x. Okay, 0, 1, 2, 3, 4, 5. Extra you must take. You can adjust the line. Minus 1, minus 2, minus 3. You observe here, minus 1 is included. So we need to keep the darkened circle. 5 is not included. So open. X value between this. All the numbers. Because x belongs to real numbers. Even 1, 1.1, 1.2, each and everything under real numbers. So you just draw the line on this. So on the line, you can just highlight this line. Is the hollow circle, darkened circle. This is the solution on the number line. So first you need to find out the solution set. Now solution on number line. We can make this way. So this finding the solution set is important, then represent on the number line. Right? Let us have one more example. That is for belongs to real numbers. Now, take one fractional question. Simplify and grab the value x on the real line. We'll ask the question. So simplify question is minus 1 by 3 less than or equal to x divided by 2 minus 1 by 3 less than 1 by 6. Okay, here is x belongs to, let's take same real line, real numbers. Minus 1 by 3 less than first 2. That means minus 1 by 3 less than or equal to x divided by 2 minus 1 by 3. 1 by 3. And next one, x divided by 2 minus 1 by 3 less than 1 by 6. Solve separately. Here is negative, take positive. Minus 1 by 3 plus 1 by 3 less than or equal to x by 2. Rule number 2 I used. Negative becomes positive by transposing one side to other side. Same way here is x divided by 2 less than 1 by 6 plus 1 by 3. Okay, transposing right side. Simplify now. Minus 1 by 3 plus 1 by 3 is 1. Or else you can do LCM and 2. Convert into mixed fraction to improper also you can make. Just or else minus 1/3 plus 1/3 is 1. Less than or equal to x divided by 2. 2 is dividing, multiply to both sides, then 2 is less than or equal to x. Let be in equation is 1. Next here, x divided by 2 less than 1 by 6 plus 3 ones are 3 plus 1. So 4 by 3. 1 by 6 plus 4 by 3 is LCM. 6. So 1 plus this 8. So 9. X divided by 2. Then x is less than 9 by 6 into 2. 2 ones are 2, 3. 3 ones are 3, 3. Cancel. So finally x is less than 3 in equation 2. Now using this both 1 and 2, solution set we can make. So solution set from in equation 1 and 2. 2 is less than or equal to x is less than 3. X belongs to real numbers. So x such that this is. Now this you can represent on the number line. So here is number line. Just you can mention here, right? So the solution set on the number line. Here is x is in between 2 and 3. 2 is included. 0, 1, 2, 3, 4, -1, so on. 2 is included, so we need to keep the darkened circle, and 3 is not included, just keep the hollow circle, just all the points in this, because of x belongs to real numbers. Okay, same way natural numbers, whole numbers, integers, they not keep the line again, just will keep the only the hollow circle, only darkened circles only can keep. Okay, when doing the combination questions also we'll see. So some more questions representing on the number line using the combining inequations I'll explain now. Combining inequations. In same linear inequations, when two inequations together will combine, and how to solve those type of problems. So graph the solution set. Question is graph the solution set. Solution set of two inequations. We'll take here. Let me take one is a 3x plus 6 greater than or equal to 9, and one more is minus 5x greater than minus 15. And here condition is a replacement set where x is belongs to natural number. When x is belongs to natural number, we need to graph the solution set of these two inequations combined, right? Okay, so first one, 3x plus 6 greater than or equal to 9, and second one is minus 5x greater than minus 15. These two will take. Okay, this first one, 3x greater than or equals to 9 minus 6. Okay, transposing. 3x is greater than or equals to 3. Dividing 3 both the sides, x is greater than or equal to 1. Divide 3 both sides. Then x is greater than or equal to 1. When x is greater than or equal to 1, let it be first one, and here is one more. Minus 5x is greater than minus 15. If we change the sign both the sides, 5x greater becomes less 15. Then x is less than 15 divided by 5. Okay, divide by 5 both sides. X is less than 3. X is greater than or equal to 1 and x is less than 3. Graphing and combination, let us see here. First one, x is greater than 1. Same, x belongs to natural number. Here also x is belongs to natural number. Now these two inequations. Let us combine these both. Graph the solution set. First graph for x is less than greater than or equal to 1. First one. So for this is x is greater than or equal to 1, and this is x is less than 3. Let's have this graph points. Let's take 0. Same positions you take and understand clearly. And this side is 1, 2, 3, 4, so on. Same 1, 2, 3, 4. First one, x is greater than 1. Okay, minus 1, minus 2. Minus 1, minus 2. So here is x is greater than or equal to 1. X belongs to natural numbers. So 1 is included. 1, 2, 3, 4, and all the values right side. So for that you can keep some 3 dots. In some books you can use maintain 3 dots also. That means is right side is infinity. So 1, 2, 3, 4, so on. And x is less than 3. 3 is not included. Only 2, 1. That's it. It's not take 0, minus 1, minus 2 because natural number. X belongs to natural number. Now graph of solution set of this x is greater than or equal to 1 and x is less than 3 together. Now if you see the graph, for the both the solutions, common solution you see once. 3 is here, not here. Common solution is only 1, 2. Okay, so using this, the solution set. Before graph, let us see the solution set for this. Only 1, comma 2. 1 and 2 is the solutions for this 2 combined. So graph for this is 0, 1, 2, 3, minus 1. So here is only 1 and 2 because of x belongs to natural numbers. Two inequations together common solution. These are combining inequations, right? Let's see even one more question with real numbers. You'll have more idea. So mostly problems will be same. Some numbers will change. So concept is same. You understand in this. Solve and graph the solution set of question number 2 in this combination. Solve and graph the solution set of two inequations. Let me take minus 2 less than 2x minus 6, and one more is minus 2x plus 5 greater than or equals to 13. So where x belongs to real numbers. These two will solve and will make the combination. Let us see how to solve. Okay, already it's given minus 2 less than 2x minus 6. Then minus 2 plus 6 less than 2x. Minus 2 plus 6 is 4 less than 2x. Divide by 2 both the sides. So 4 divided by 2 less than 2x by 2 is 2x divided by 2. Then 2 is less than x. So 2 is less than x means x is greater than 2. Okay, 2 is less than x. So x is greater than 2. Now from this side, minus 2x plus 5. So minus 2x greater than or equals to 13 minus 5. Minus 2x is greater than 12. If you interchange the sign, minus 1 both multiply both the sides, inequality sign will be changed. 2x minus 12. If you multiply with negative 1 both the sides, inequality sign should be reverse. Right? Remember that. Then x is less than or equals to minus 12 by 2. X is less than or equal to minus 6. Yes, x is greater than 2 and x is less than or equal to minus 6. These two will take the common solution, representing these two together. Let me take two lines, same type. X belongs to real numbers. Okay, first one is x is less greater than 2, second is x is less than or equal to minus 6. Same, x belongs to real numbers in this, x belongs to the real numbers. X is greater than 2. If you take 0, 0, positive 1, 2, 3, 4, same 1, 2, 3, 4. Less than minus, this side is minus 1, minus 2, so on. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. One more is there, like minus 7. Because value is given here. Minus 3, minus 4. Let us see here. X is greater than 2. 2 is not included. X belongs to real numbers, no? Greater. So right side all the values. From 2, all the values is right side. Second one is x is less than or equal to minus 6. Minus 6 is included. From this, all the values towards left. All the values are this side. So there is no common, if you notice. There is no common. So then solution set you can write separately. So solution set is, together you can write x is greater than 2 or x is less than or equal to minus 6, where x belongs to real numbers. Now these two together on the same graph. Same graph we can represent. That is, so we need 0, 1, 2, 3, so on. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, so on. these two together. So first one is x is greater than 2. 2 is not included, all the values are this side, and minus 6 dot darkened circle and left, because x is less than or equal to minus 6. Okay, so this is the graph for this. So graph of the solutions set x is greater than 2 and x is less than or equal to minus 6. Together we can write. So this is the combination, combining inequations. We can use this problem. Along with this, some more zero product rule. Even in inequations, we have some problems. We'll solve those. So in this linear inequations, we need to understand one more product rule. So for example, if you see one statement like x minus 3 into x plus 5 is less than 0. If product of two expressions is less than 0 means, so either x minus 3 is positive, then x plus 5 must be negative, because plus into minus or minus into plus only is negative, because this value should be less than 0. To make this as negative, if x minus 3 is positive, then x plus 5 is negative, or else if x minus 3, if it is negative and this should be positive, then only this will be less than 0. Two cases. And same type, if x minus 3 into x plus 5 is greater than 0. So when the product of two expressions will be greater than 0, then when both are negative or both are positive, only greater than 0. So we know that minus 2 into minus 3 plus 6, right? Normal, minus 2 into minus 3. There is nothing but plus 6. So it's greater than 0. Or both are positive, plus 6, greater than 0. So when this both are negative or both are positive, value is greater than 0. One is negative and one is positive only, less than 0. Okay, so in this case, if you see the case 1, how to represent this type or number line. Here is when two cases. When x minus 3 is once if we take less than 0, then x plus 5 must be greater than 0. X plus 5 greater than 0, because product is negative. So one should be less, one should be greater. So from this x is less than 3, minus 3 take. And from this x is greater than minus 5. X value is less than 3 and x value is greater than minus 5. X value is less than 3 means 2, less than 3 means like 2, 1, 0 all. But x value is greater than minus 5. So already x is less. For example, if you observe here, take the small number line in this case. Together, if it is possible, x is less than 3. Now if it is 3, this side all the values. X is greater than minus 5. So there is a minus 5. From this side all the values. So the result is in between 3, minus 5 and 3. Okay, the common solution. Apart from that, if you see one more case, case 2 in this, if you take reverse. First one is x minus 3 is greater than 0. Then x plus 5 is less than 0 if you take. Okay, first one is negative, greater, positive, second is less, negative. If x minus 3 is greater than 0, then x is greater than 3. If x plus 5 is less than 0, then x is less than minus 5. X value greater than 3 and x value is less than minus 5. Okay, is it possible? X is greater than 3. In this number line, x is greater than 3. 3 is here. X value greater than 3 means from 3 right side. X is less than minus 5. From minus 5 to this. So it's not possible. There's no common solutions. So only the solution set is x value between minus 5 and 3. Okay, x is less than 3 and x is greater than minus 5. These are the thing. So only between minus 3 and minus 5 only you can consider. So together we can make minus 5 less than x minus 3 for this case. Minus 5 less than x and plus less than 3. So x value between minus 5 and 3, minus 5 to 3, right? If the natural numbers, whole numbers, integers, based on that we can represent on the number line. Same way, if it is greater, so both should be positive and both should be negative. So let me take both negative. X minus 3 is less than 0, x plus 5 also less than 0 you can take for your case 1. In this case, x is less than 3, x is less than minus 5. X is less than 3 and x is less than minus 5. This, if you see a number line, x is less than 3. 3 is this. Less means all values are this side. Let me take the color. From 3, writes all the values. X is less than minus 5. This is minus 5. Means again this side. Okay. So this area is common. Minus 5 to left is matching. Matching values are this only is a matching now. X is less than minus 5. So values which are less than 3, they are less than even minus 5 also, right? Now if you see the case 2 in this purpose, second type, which one? X minus 3 greater than 0 you take, and x plus 5 greater than 0. Both are positive, both are negative. There only is greater. For this case, x is greater than 3. In this case, x is greater than minus 5. Okay, this if we represent on number line, see once. X is greater than 3. This is 3. From 3, all the values right side. X is greater than minus 5. Minus 5 here. From here, all the values right side. So common part is this. That means x is greater than 3. So these two together, these two are the solutions now. So solutions for set for this is x is greater than 3 and x is less than minus 5. We can represent. So from 3 to right side all the values, from minus 5 to left side all the values. Okay, in this way just represent. The main thing what I want to explain here, when product is less, two cases, one should be positive, one should be negative, or first one is negative, second is positive. If the product is greater than 0, both are positive or both are negative. Okay. In case the problems, questions they ask in this type, you can consider two cases you need to solve. Not only take separately. So two cases separately you have to solve and together you can represent on the number line. Okay. So these are the basic things about this product rule inequations. So those are required to learn each and everything, just to go in order chapter wise, and links are providing in the description below. Based on that you can go through, right? Those are watching first time, you can subscribe to our channel, and topic wise and chapter wise if you are revising it'll be perfect, and remaining syllabus or remaining chapters links are providing in the description below, you can go through it.